In this video, I'm going to go over finding the surface area of many different shapes. Like I've done in the past for these videos, there are a lot of questions, a lot of problems, which I'm not going to do all of them. So I picked and chose some different, a variety of shapes, if you will, some different ways to find the surface area. I think the biggest thing when you do these is, since you know the formulas or they're given to you, is to really think about what you're actually finding when it's asking you to find the surface area or the lateral area of these shapes. Okay, so I'm going to start off by looking at this third one, finding the lateral area and the surface area of this solid below. Now, one of the first things I notice in reading this is it does tell us that the base is regular, and that's something we've been talking about for a few weeks now, right? So that means it's equilateral and equiangular. It's going to help us later on in this question. Okay, so I'll start with the lateral area, and again, this is just copying down from your formula sheet. That is equal to 1/2 times the perimeter of the base times the slant height. Okay, so plugging in here, I have my base is an equilateral triangle with side length of 4 centimeters. So that perimeter is going to be 12. And the slant height is given to us, that's right here, of 5 centimeters. So my lateral area is going to be equal to 30 centimeters squared. Okay, let's do the surface area. Now the surface area is going to be equal to the area of the base plus the lateral area, which we already found is 1/2 times the perimeter of the base times the slant height. So we do need to find the area of the base before we can continue. So I'm going to go ahead and draw a triangle here. And again, this is an equilateral triangle with the side lengths of 4 centimeters. So I'm going to go ahead and draw that line down to make it into a right triangle, splitting it in half. So that's 2 centimeters. We know this side is 4 centimeters. And we also know that this angle is 60 degrees and that one is 30 degrees. So using our understanding of our special right triangles, we should find that the height of this triangle to move from the small leg to the large leg is going to be multiplying by √3. So it's going to be 2 times the square root of 3. So to find the area of the base, I'm going to do 1/2 times the base times the height of 2 times the square root of 3. Okay, adding in, I already know, is 30 square centimeters. I'm going to go ahead and do some math here. That's going to be half of, I guess my brain is seeing is this half and this 2 will make 1. So this is going to be 4 times the square root of 3 plus 30. And then I'm going to go ahead and write my non-radical first, but it doesn't matter, your call. And that's going to be square centimeters. Okay, so that is it for the surface area and the lateral area in number 3. All right, you can see I've already done 4, so let's jump to number 5. All right, this one is a lot of fun. Okay, so this one in this figure, we have a prism, and then on top of that prism is a pyramid. So what I've done in my prep for this is I've thought about, okay, how can I find the area, the surface area of this figure? And so what I was thinking is, you can see by my LA and SA, is that if I find the lateral area of the prism, so like this front face, the left face, the back face, and this side face, right? So don't do anything with the base. But then I find the surface area of this pyramid. That would then include finding the area of that base, which I know is not actually part of this, but it is the same as the base down here. So all of that together would actually help us find the surface area of the figure. So I'm going to say the surface area is the surface area of the pyramid plus the lateral area of the prism. That is what I'm going to find. Okay, so our formula for the surface area of a pyramid is going to be the area of the base plus 1/2 times the perimeter of the base times the slant height. And the formula for the lateral area of a prism is equal to the perimeter of the base times the height. All right, so plugging in, I'm going to find that the area of the base, look at my pyramid, is that square of 11 times 11, so 11 squared, plus 1/2 times the perimeter, right? And the perimeter of the base is going to be 11 times 4, which is 44. And then the slant height for that pyramid is going to be 12. and then plus, now I'm looking at the prism. The perimeter of the base is again that 11 times 4, so 44, and then times the height of the prism is 11. So plugging this into a calculator would allow us to find all of these numbers. So I'm going to go ahead and use my calculator. So I've got 121 plus, and then I've got here, I've got, let's see, half of 11 times 4 times 12. So 0.5 times 11 times 4 times 12. And then plus my last one here is 11 times 11 times 4. So 11 squared times 4. All right, so that's going to give us a total surface area of 869 square meters. 869 square meters. Okay, so that is how you find the surface area for this figure. Okay, going to number 6. Now, in number 6, you'll notice that we have 2 cones back to back. So what I'm going to do is I'm going to find the surface area of this figure by finding the lateral area of each of these cones and adding them together. So my surface area is going to be the lateral area of cone 1 plus the lateral area of cone 2. Okay, now it doesn't matter which one you want to choose, but when you write the formula for these lateral areas of cones, you're going to have pi times the radius times the slant height for each of them. And what you should know is that we can find the radius of these, and we know we're going to use pi, but the slant height is something we don't know. So I'm going to go ahead and kind of draw 2 triangles here. So here's I'll use as my left cone. So this is 15 centimeters here, and then we have our 8 centimeters there. All right, and then we are going to have our right angle, so we need to figure out the slant height, which is going to go there. So that's going to be using Pythagorean theorem. So 8 squared plus 18, not 18, that was 15 squared, there we go, equals the slant height for this left cone. All right, so that's 64, that's 225. And then that's going to be, let's see, 289. So the slant height for this one on the left is the square root of 289, which I know is 17. Again, use the calculator if you don't know that one. All right, but now I need to do another triangle. All right, that was for the left cone. Let's do the right cone. So the right cone has 18 centimeters here. It has 8 centimeters there. So we're trying to figure out what this slant height is up there. So I'm going to use 8 squared plus 18 squared equals our slant height. So 64 plus, let's see, is that 324? Let me check. It's been a while since I've done 18 squared. It is 324 equals our slant height squared. Adding those together gives us 388. All right, and then so L is equal to the square root of 388. Okay, now when I do this one here, all right, because I'm going to be plugging it into another formula, is I'm not going to find a decimal approximation for that. So I'm going to wait till the end before I actually do that. Okay, so what I'm going to do is I'm going to plug in my numbers now to get pi. The radius is 8 for both of these. I'll do the slant height for the first cone, the one on the left we said was 17. We found that one. Plus pi times 8. And I'm just going to plug in the square root of 388. Now that will allow me to get an approximation. So let's plug in here. So we have our first one is pi times 8 times 17. I'll confirm that. I'm pretty sure that's right. Plus, and then pi times 8 times, I believe it was the square root of 388. All right, I think that's correct. All right, so approximately this is going to be 922. I'll just do to the nearest tenth, 0.3, 922.3, 922.3, and this is square centimeters. Okay, so again, we've talked about this in class, especially with that CLT from a few lessons ago, is that please don't use rounded stuff until the end. Don't round until the end, right? So you'll get students that would find the square root of 388 and round it first, and then you're going to get off like on the rounding at the end, it's going to be off by a little bit, right? So this number here might not be the same. So I'm just trying to keep you from losing points on one of the assessments. Okay, next one, number 7. We'll do 2 more. All right, so number 7 is wanting us to find the surface area of the figure below. All right, you can see that our base is a regular pentagon. So I'm going to plug in the surface area. Formula is 1/2 times the apothem times the perimeter, which is the area of the base. All right, plus, and that's going to be 1/2 times the perimeter of the base times the slant height. Okay, now we do know the apothem, right? The apothem is 4.1. You can see it there. The perimeter of the base is 6 times 5, which is 30 inches. Plus 1/2 times, we know the perimeter of the base is 30 again. And then we just don't know the slant height. So I'm going to go ahead and use this triangle that they've kind of shaded for us. I'll kind of highlight it for you right there. All right, so we need to find this slant height right there. So I'm going to draw that triangle. Okay, that right triangle. This is 11 inches. This one is 4.1 inches. So I'm trying to find that slant height. So 4.1 squared plus 11 squared equals my slant height squared. I don't know 4.1 squared off the top of my head. I do know this is 121. So we can find 4.1 squared, which is 16.81. And that's equal to our slant height squared. So adding those together is going to give us, let's see, 0.81. That's going to be 7, and that's 3. So 137.81. So again, like I did before, I'm just going to write slant height is the square root of 137.81. I know it looks like I've rounded, but I have not, right? Because they gave us 4.1 as our apothem. All right, so again, with this is I'm going to plug in that square root of 137.81 into my formula, which means I'm not going to round until the very end. So let's go ahead and type this in. So half of 4.1 times 30. So half 4.1 times 30. And then plus. This next one is half of 30 times that square root. So half times 30 times the square root of, I believe it's 137.81, yes. And approximately going to be 237.6, 237.6. So 237.6 square inches. Okay, so that's it for number 7. All right, last one, number 8. Oh, I lied, we got 2 more, yay. Number 8, we'll do number 9. Number 8. So in this one, it's wanting us to find the surface area of the figure below. All right. And when we do this one, we're going to leave it in terms of pi, right? It says to leave our answer in terms of pi. So basically, when I look at the cylinder, they've cut out this prism. So to find the surface area of this figure, I need to find the surface area for the cylinder. All right. Then I'm going to add, right, I'll try to highlight it for you. If you look here, we've got these spots here for this prism, right? That's going to be values we need to include. So I'm going to add the lateral area of the prism that's inside there. But then I need to subtract, because they're not filled in, right? I need to subtract these 2 squares that are kind of holes, if you will. So I'm going to say, let me do this actually real quick. Let's say minus the area of the 2 squares. Okay? All right, so let's plug in all our formulas here. We've got the surface area for a cylinder, which is 2 pi r squared plus 2 pi r h, plus the lateral area for a prism, which is the perimeter of the base times the height, and then minus the area of a square, which is side squared, but we've got 2 of them, so 2 times side squared. All right, let's plug in our stuff. Our radius is going to be, if the diameter is 12, then our radius is going to be 6 yards. All right, so I'm going to plug in 6 squared plus 2 times pi times 6. And the height is going to be that 25 yards. Plus the perimeter of the base is going to be that 16, right, for this prism here. So you can see that each one is 4 yards. There's 4 of them, so 16 times the height, which is 25, and then minus 2 times our side of 4 squared. All right, so all of that's going to be our surface area. So let's simplify. That's 36 times 2, which is 72 pi, plus that's going to be, let's see, 25 times 2 is 50, times 6 is 300 pi, and then plus 25 times 16, let's see, 25 times 10 is 250, 6, let's see, that's 6 left over, 6 25s is going to be 150, so that's going to be 400, and then minus 16 times 2 is 32. All right, so all of that, again, we're going to leave it as an exact answer, is going to be, let's see, 400 minus 32 is going to be 368, and then plus 372 pi, and this is looks like it's going to be square yards. All right, so that is it for number 8. Again, I think this is the hardest part here, is just to figure out this very first step of what kind of equation we're going to do to find the total surface area. Okay, last one, number 9. Okay, so looking at this figure, we've got a prism, and then we have a pyramid on top of it. So my thought here to find the surface area for this figure was, what if we found the surface area for the prism? Okay, so we're going to find the surface area for the prism, like kind of the bottom part of the figure. And then we're going to add the surface area for the, the lateral area for the pyramid, right? Because I don't want to include that base of that one. But then, because if I did this, if I stopped here, I would have too much, right? I would still be including this value, this area in my surface area, but I can't, right? Because it's not actually exposed to, outside of that figure. So I need to subtract, right, that base or that square, okay? So let's plug in our formulas here. The surface area for a prism, that is going to be our 2 times the area of the base plus our perimeter of the base times the height. Then we're going to add the lateral area of the pyramid, which is 1/2 times the perimeter of the base times the slant height. And then we're going to subtract the area of that square, which is side squared. All right, so I'm going to do the area of the base, and this is up to you. It depends on, which key, my key or Mrs. Carr's key. It doesn't matter. It's your call. My brain sees this as the base of this prism, but feel free to use a different side. It shouldn't matter in the end. So I'm going to say the area of the base is 10 times 6, plus the perimeter of the base then would be, let's see, if this is 10 and this is also 6, that's going to be 20 plus 12, which is 32 units, times the height of 12, plus, now moving to the pyramid, the perimeter of the base of the pyramid is 6 times 4, which is 24 millimeters, times the slant height, which is given, which is 11.5, and then subtracting that area of the square, which is 6 squared. All right, so we can go ahead and type all this in to a calculator. All right, so I've got 2 times 10 times 6, and then 32 times 12, so plus 32 times 12, and then plus half of 24, which is 12 times 11.5, so 12 times 11.5, and then I need to subtract out 36, right? Subtract out that 36, so my surface area is 606 square millimeters. All right, guys, that is it for this video on surface area. It is a lot, I get it. So take some time, find some time, carve out some time for you to practice these and come see us with any questions. Good luck.